This is the weapon system for my robot Magneato, rebuilt for Motorama 2016. I'll do a quick walkthrough on how it works because some of my pictures may not have made it too clear. The basic concept is the same as previous versions. The goal is to store energy in a large flywheel, which is here, and then by way of a clutch and some gear reduction, transfer that energy into a flipper arm. So the first thing I'm going to do is a quick demo on it kind of actually working in slow motion. I have a battery here that I can plug into the magnetic coil, and I'm going to spin the flywheel by hand and then turn the clutch on, and you should see the arm go. So what's really happening there is that when I turn the magnet on, the flywheel that's already spinning is getting attached to the shaft here. You can see this collar on the front that's hard attached to the shaft. It will start spinning, and that causes a rope to be wound up and fire the flipper. So I'm going to take the clutch assembly apart, and then we'll do a little close-up version of how the ropes are actually used to make this happen. Okay, so first things first, take the power away. One shaft collar on the end here is used to tension the spring that connects the flywheel and the lock, what I call the clutch lock plate. So the flywheel is free spinning, the pulley is bolted directly to it, and there are bearings pressed through the whole bunch. So it's like a little mini shell spinner. So take the flywheel off. You can see that it's just a big shell. And you can see the bearings down in the middle there. So this is what I call the lock plate. And there's a little disc spring in between the two. And the point of the disc spring is to make it so when I turn the magnet off, it separates the two plates as quickly as possible to cause them to disengage. So this lock plate started as a commercial magnetic clutch pulley. So this is the off-the-shelf part. You can see there are ribs there to run the belt on the car, fan belt on the car, and there's a bearing in the middle. And I pressed the bearing out, turned all the ribs off, and what you get is this lock plate. So I had to make this hub that goes on the inside of the lock plate that is keyed. And so when this part turns, it causes the shaft to rotate, and that's the whole concept. So when it's not flipping, this is not moving, but the flywheel is moving. So when I want to turn it on, the goal is to turn the magnet on to latch this to the inside of the flywheel, and that's what makes it actually move. So the thing that does that is this big electromagnet here. And this is another stock component that comes from the electromagnetic clutch. This is an old one that I burned up by accident. I drilled mounting holes, I think you can see them there. I drilled mounting holes on this inner flange, and then bolted it to a plate inside the robot. And the idea is that that magnetic field will go through this lock plate and actually draw the flywheel into it. Okay, so I'm going to put it back together here. Lock plate first. Get the key wheel lined up. There we go. Then the disc spring. And the flywheel. Needle roller bearing, thrust bearing, shaft collar, and tighten the collar down. Back in business. So if I did that right, I should be able to do another quick test here. You can see that time the flywheel is still rotating the same direction it was when I spun it. And the goal here is that I will pulse the magnet, so I turn it on just long enough for the arm to fire, then I turn it off, and the flywheel maintains whatever energy it didn't use. That's going to be all about the timing of the microcontroller. I don't really have that control circuit set up yet. Right now it's just my hand. Okay, so we're going to switch and look at the rope here. So, go ahead and plug this guy back in. Alright, so the goal of the whole system is to make this shaft rotate, which winds in the rope. So I'm going to turn the clutch on, and then wind in the rope. And you can see, I'm not sure the camera shows it that well, you can see a rope here is actually pulling on this rear hinge pin, and that's what's making the arm move. We can do a close-up view here. Okay, a little closer up here. The rope in this system is blue. You can see it here. It goes around the rear bar. Okay. And there's a small piece here that the rope goes through to force it to wrap around the clutch axle. So I'm going to rotate the clutch axle using this shaft collar. And you can see, as it winds in, the rope goes tight, and there's a roller here on the rear bar that acts as a block and tackle to give me a little more gearing. And when it hits the end of the stroke, you can see that the rope is coiled around that flywheel axle here, making everything tight. When I turn off the magnet, it should reverse. Everything should set.